Good day, ladies and gentlemen. Today we're gonna be doing grade 11 trigonometry. So in this case, we're looking at question 1.9 exercise 1.9 previous exam. So this is a previous exam question paper, and here we're told that in the figure below, the point P -5 and B is plotted on the Cartesian plane, and we're given that OP is 13 units and RQP is equals to A. In this case, we're given a Cartesian plane. So because we have this Cartesian plane, we have a straight line that's moving from point O to point P. But then when we see this line, we always have to draw a vertical line towards our x-axis, because then we form a triangle, and it's going to help us calculate values that we're not given. Like in this case, we're not given the value of B. So as we come to this scenario here, as you can see, I've already drawn my triangle, and I've drawn my vertical line towards my x-axis. Always draw your vertical line towards x-axis. In this case, we're going to solve for what we don't have. So we have r squared, which is then our hypotenuse. So then we're going to say that we basically now have 13 squared, right? So we're saying that we have 13 squared is equals to -5 squared, because it's on our x-axis, plus y squared. In this case, this becomes 169 is equals to 25 plus y squared. And the reason why we're doing this is because it's going to help us solve for what needs to be done as we continue the question. So this becomes 169 minus 25, which is equals to y squared. In this case, you're going to take your calculator, and then you're going to subtract 169. So you're going to say 169 minus 25, which is 144. So you're going to have 144 is equals to y squared. So we know that we're going to do the inverse of squaring, which is square rooting. So this becomes a plus or minus, because then we're solving for the length of b, right? We're solving for b. So in this case, square root of 44 is 12, so is equals to y. But because it's in the second quadrant, we know that as we move up our Cartesian plane, the y values here are positive. They are positive here, and the x values here are negative. So we know that therefore y is going to be positive 12. So we're going to put the positive 12 right there. There we go. Now that we have finalized our triangle, we can now continue to actually solve for the trig ratios. Maybe we're going to be asked to calculate sine alpha, all of these things, and then this is going to help us. So let's look at this. So here we're told that find the values of cos alpha. So in this case, we know that cos alpha is therefore adjacent and hypotenuse. So because it's cos, it's adjacent and hypotenuse. So then we therefore say that because it's cos, let me just erase this part here. I'll just erase that part, since we already know what's in our Cartesian plane. I'll just erase this right. Okay, perfect. Now we're told to find the value of cos A. So we know that cos A is actually what's this? We actually say that cos A is adjacent and hypotenuse. So we're gonna say that cos alpha, why am I saying cos A? It's cos alpha. Adjacent. So what's adjacent to it? It's -5, right? And what's the hypotenuse, which is 13? So we're gonna leave our answer, and then you get your full 1 mark. You basically get 1 mark for this, so you get a mark for that. So that's the answer there. Cos alpha is that. And then you have one here where you have tan 180 degrees minus alpha. Okay, now when you see something like tan, right, you have tan 180 degrees minus alpha. We actually apply reduction, so we have to reduce the angle, because 180 degrees, if we look at 180 degrees minus alpha, we know that this is a reduction according to our Cartesian plane, right? We know that here we have theta. It starts off with theta, and then we know that here it's always 180 degrees minus theta. You agree? And then on the third quadrant, it's 180 degrees, 180 degrees plus theta, and then on the fourth quadrant is 360 degrees minus theta. And then we actually apply reduction. So because it's in the second quadrant, we know that it's tan 180 degrees minus alpha. So just explaining the reduction parts. So that means this is in the second quadrant, and we ask ourselves, how does tan behave in the second quadrant? Tan is negative. According to the cast diagram, we say that we have all the trig ratios that are positive, and we have sine that's positive here, and then all the other trig ratios are negative. and then we have so we have all the trig ratios positive there, sine is positive there, and we also have tan is positive here, and we know that also cos is positive in the fourth quadrant, and all the other trig ratios are negative. Hence it's actually called a cast diagram. If we move from this side here, so if we move anti-clockwise, you'll see that it's actually a cast diagram. So it's a cast diagram for everything. So you have cos, then you have all the trig ratios that are positive, sine is positive there, all the other trig ratios are negative, tan is positive there, all the other trig ratios are negative. Now let's look at this. So you have 180 degrees minus alpha, so we know that it's actually minus tan, right? So it's minus tan alpha, because negative tan alpha, because tan in the second quadrant is negative. So now we have to find the value of this. So this becomes negative tan alpha. So we know that tan is opposite and adjacent. So what's opposite alpha is 12. So we have 12 and negative 5. So this becomes 12 over negative 5. You can simplify it further if possible, but in this case it's not really possible. So your answer is 12 over negative 5, because it's opposite and adjacent. And then for cos alpha it's negative 5 over 13. So if we look at this, we've already tackled the first two questions here. So you have 1 mark there, and you're gonna get 3 marks. You actually get a mark for reducing the trig. You actually get a mark for reduction part, for reducing the angle there, because we work with acute angles, you see. So then we get a mark for reducing. You also get a mark for your for your answer, and also because it's negative, you're also gonna get a mark because it's negative tan a, because it behaves it's negative in the second quadrant. So hence you get 3 marks there, and hence there you actually got 1 mark, because it's pretty straightforward that it's gonna be opposite, it's gonna be adjacent, and then hypotenuse. Okay, now let's move on to the next question, which is having to simplify, right? Okay, perfect. Now before we move on to simplifying, let me just fix this really quickly and erase this board. Let me just put this in. Okay, and then let's erase the board. I think we got that part right, né? Okay, perfect. Let me erase this part. I'll just also erase the cast diagram. You can always go back and then check them out, take the notes, and then you'll see how it goes. The next question is, I think it's having to simplify, but yeah, you'll see how it goes there, and we will move. Okay. Let me just okay. Yo, it's a mess. I need to get proper. Oh, it's a mess, but it's fine. Sorry guys, this is quite long, 8 minutes. Yo. Okay, so let's look at this here. So we're given consider that you have sine open brackets theta minus 360, and then sine open brackets 90 degrees minus theta, and then tan open brackets negative theta over cos 90 degrees plus theta. And then we're told simplify to a single trigonometric ratio for 5 marks. Okay, so let me just rewrite this part then. I'm just gonna rewrite that part there. Nah, I'll just rewrite it. So this is sine, right? Sine open bracket, you have theta minus 360 degrees, and then it's going to multiply with sine open brackets 90 degrees minus theta, and then you're gonna have tan negative theta, right? You're gonna divide this by cos, right, open brackets 90 degrees plus theta. So here we're going to apply reductions, co-functions and stuff as we proceed. So let's look at this. Let's simplify this to a simple trigonometric ratio. So if we look at sine and open brackets theta minus 360 degrees, it looks funny, right? And we have to change that. So we normally say that if it's a negative angle, we normally add 360. So this becomes, if we add 360, it becomes theta minus 360 degrees plus 360 degrees. Sorry for that. That means this and that will cancel, leaving you with sine theta. So we're just going to leave that as sine theta. I'm going to try cut this video short. Let me just cut it now, and then I'm gonna do the second part.